In this lecture, I'm going to show you how to configure OSPFv2. OSPF version 2 is used to advertise IPv4 routes only. So to start with, this topology here is single area OSPF, and in the new CCNA exam, there's only coverage of single area OSPF. To start with, so there's three routers, they're all interconnected, and I'm going to assign them to area 0. So they're going to advertise OSPF just to area 0. Each router has a switch connected. In this case, router 1 has a host connected, or it could be multiple hosts. And switch 2 has a host connected as well. And switch 3 has a server connected. And so the router interconnects are using 192.168 IP addressing. And the inside interface, the LAN interfaces, are using 172.16 addressing. In this case, for router 1, it's got 172.16.1 subnet connected on the inside interface, and switch 2's got 172.16.2, and server 1 is using 172.16.3 subnet. And it's important to know the subnets because that's what's going to be advertised to area 0. And by doing that, then you have layer 3 connectivity from host to server. So with host 1, it's going to, whenever there's a whenever it wants to send packets over to server 1, what it'll do is it'll forward packets to this inside interface on router 1. That's FA20, that's its default gateway. And host 2 has a default gateway, and so does server 1. So the first thing I'm going to do to start with configuring OSPFv2 is I'm going to go to each router and enable OSPF. So I select router 1. So I'm going to sign on. And I'll show you the routing table. Show IP route. And in this example here, they're all just connected routes, so there's nothing else. So router 1 only knows its connected routes. So 172.16.1 is a connected route, and that's the inside LAN interface for the hosts. And then it's got connected interfaces for 192.168.1 and 2. And those are connected interfaces. So it knows of the IP. The IP addressing is already configured on the routers, and the interfaces are enabled. So router 1 knows of router 2 because it's directly connected. It knows what the IP address is. But if you want to do routing, you have to actually know of more than just the connected routes. You have to know of routes that are more than one hop away, and that's what routing will do. So what I'm going to do is go to router 1 and go configure terminal. And the first thing I want to do is enable globally OSPF. So router OSPF and assign a process ID. And what I want to do is now assign a router ID. The purpose of a router ID is to whenever OSPF sends routes, it is uniquely identified by the router ID. So in this example, router 1, I'm going to assign 192.168.2551. So whenever you set up adjacencies, whenever routing updates are sent, each neighbor router identifies its neighbor by that router ID, so it has to be unique. So that's the command there. Now I'm going to enable routing on interfaces, and that's done through network commands. So if I type 192.168.0.0, then I'm going to use the wildcard 00255.255. I'm going to assign it to advertise to area 0. So what this does is this says take any 192.168 subnet. So that it could be 192.168.1, 2, right up to 255. So all of them. Advertise them to area 0. So any interface that's assigned to a 192.168 subnet will advertise OSPF 192.168 through that interface to its neighbors. And that's all it's really doing. The other command I have to do is 172.16 because I have to do the LAN interfaces as well. And that's 172.16. So in this case, I'm just going to use a slightly different mask. telling it to advertise it to area 0. So in this case, this is 172.16.1, and what I've done is I've masked it up. I've used 0.255, so it's masking off, actually that's not correct. It should be just all zeros. So I'm going to go 0.0.255 in area 0. And what that does is it masks off 172.16.1 with all those 3 zeros there. And it says advertise anything from 172.16.1. And that's what this is here. And then I'll go to router 2 and do the same thing. So I'm going to first start out with a router OSPF, then I'll process ID 1. And I'm going to give it a router ID of 192.168.255.2 because it's router 2. It's somewhat arbitrary, but if I give it a 2, then I know what router I'm looking at when I'm going through some commands, so it makes it easier to troubleshoot. Then the same kind of network command, .0.0 for all the 192.168 subnets. Then I want to mask off just the first 2 octets, and then tell it to advertise to area 0. That's where all the routers are interconnected. And the next command would be 172.16.2.0. This would be, the mask would be slightly different. It would be 0.0.0.255 because I want to mask off 172.16.2. I'm being a little more specific this time. And 172.16.2 is this LAN subnet here that I want to advertise to area 0. So then that's area 0. And I just forgot the network part of it there. So that's that there. And that's all there is to advertising then from router 2. Just verify the work is okay. Then I'll go to router 3, enable Cisco NAT, and I'm going to do the same thing. I'll go router OSPF1, same process ID, and router ID 192.168.255.3 for router 3. Then I'll start with my network commands. They'll be the same commands, so I'm advertising the same routes. And then wildcard. And then to area 0. So verify everything's okay there. It's just masking off 192.168. That's what the zeros on the wildcard mask do. And then the same thing here. I want to do the server subnet. Advertise that to the other routers so they know it's there. And that's 3.0. And I could do 172.16, but I'm just deciding to be specific and say just that subnet. 0.0.0.255, and then to area 0. And that looks okay there. So what I'll do is, for network convergence, when I do fast forward time, I'm telling the routers to exchange routes. So what I do is go show IP route. So I've got my OSPF routes in there. There's the connected routes that are already there. Connected, this is router 1, so it knows about 172.16.1. And it also knows about the directly connected neighbors. But now it knows about 2.0 and 3.0 subnets and 192.168.3. So 192.168.3 from router 1, that's over here. So it's learned about that route from router 2 and probably router 3. Because there's 3.0, so it's learned it from 2 different sources. There's 3.0, see it's got 2 routes there. And same with 172.16.2, that's the that's coming from router 2. And 172.16.3, that's the server subnet. So it knows about 172.16.2 and also 3. Same on router 1 here. So it knows about those routes. And I'll go show IP OSPF neighbor. These are for neighbor adjacencies. And router 1 is using 192.168.255.1, so it knows about 2 and 3. So 2 is router 2, 3 is router 3. So though it has full adjacency with those neighbors. And on the interfaces as well shows them. So that's all confirmed. And now I'm going to ping from host 1. I'm going to ping the server from host 1. 3.1. So it knows about the routes. It starts with updating route, the YARP table, and there it is there. So I got 3 replies. Try it again. Now I've got 4 replies. So I'm replies from server 1 to host 1. So I'm connected from host 1 to server 1. Do the same good thing with host 2 as well, just to verify. There's connectivity there. And I'm getting all 4 replies immediately. So there's connectivity right through from the LAN interfaces on both LAN segments from routers to server 1. And if I go to router 3, I'm going to show IP OSPF neighbor. And so there's 1 and 2. Those are the neighbor IDs 1 and 2, and that's router 1 and router 2. And there I am on router 3. So full DR, it's full adjacency. And that concludes OSPF routing.